Hello everyone, and good morning or good afternoon, depending on where you are joining us from, and welcome to today's webinar. My name is Annabelle Chaplin from the Business Review, and I will be your host. It is our pleasure to have ExxonMobil with us today, who will be discussing new gases, new challenges for gas engines. Today's guest speakers are Oliver Glove, an equipment builder engineer, and Katha Tellier, the Advanced Engineering Associate of Products Technology at ExxonMobil Research and Engineering. I'd like to welcome you to our webinar platform on 24. You'll notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link that you received via email to rejoin the session. In order to ask questions, you can send them in via the questions widget, which is located at the bottom of the page. Just type your question into the box at the top left-hand corner of your screen and click Submit. We will allocate around 10 to 15 minutes at the end of the session to address any questions or thoughts that you may have. If you click on the survey widget, there are a few questions in there for you to answer in order to provide feedback. You can do this after the webinar. Please use the yellow Help widget if you require any assistance. You can move, resize, and maximize the windows in front of you to get a better view of the slides. But now, please allow me to welcome Oliver Glove.
Yeah, thank you very much, Annabelle, for the introduction, and I will now start the presentation. So, ExxonMobil celebrates 50 years of Mobil Pegasus gas engine oil series in 2015. Get proven performance for your gas engines. ExxonMobil offers specially formulated high-performance lubricants for a variety of gas engine technologies, including the latest designed highest efficient stationary gas engine models for natural, landfill, sewage and biogas applications from the leading gas engine builders. In combination with our Signum used oil program and our field engineering services, you can trust not only on the oil, you can trust on the ExxonMobil lubricant solution for your application. For over 50 years, Mobil Pegasus series has delivered leading-edge technology that can result in optimum engine life and low maintenance cost. ExxonMobil has a long and strong history in gas engine oil technology with own developed and own manufactured products. We are using this knowledge to develop lubricant solutions to protect your gas engine application on the highest level for the past, for the present, and also in the future. Mobil SHC Pegasus and Mobil Pegasus 605 Ultra 40 continues that tradition as the latest evolutions in the Mobil Pegasus line, formulated and tested in a wide range of operating conditions and in a variety of gas engines. The result, the Mobil Pegasus gas engine oil series, helping to provide engine protection and long oil drain intervals, which can minimize maintenance outages and shutdowns and increase your productivity. The Mobil Pegasus product line is designed to handle a range of gas engine designs and fuel gas types found in today's energy operations, equipped with extensive builder approvals and proven field performance. In addition to laboratory, bench and engine test rigs, Mobil Pegasus oils are rigorously tested in the field before they are commercialized and are recognized by equipment builders. For example, Mobil Pegasus 1005 was tested for a total of more than 40,000 hours on Caterpillar, MWM, GE Jenbacher and Waukesha gas engines at locations around the world before commercialization. The ExxonMobil Equipment Builder Group, celebrating 100 years of technology leadership, partnership and expertise in 2014. In 1914, the ExxonMobil Equipment Builder Group began to partner with leading manufacturers to help them optimize the performance of their equipment. For the past 100 years, working in more than 150 markets, the ExxonMobil Equipment Builder Group has devised pioneering ways to enhance equipment efficiency, created new lubrication approaches to advance customer productivity, understood equipment trends, current and future lubrication requirements, engaged key builders to develop strategic technical and commercial relationships, and designed and overseen innovative testing programs. This collaborative approach has elevated ExxonMobil's state-of-the-art application expertise and enabled our partners to achieve new heights of equipment performance. The ExxonMobil Equipment Builder Group will continue to extend its extraordinary legacy into the future while delivering a valuable competitive advantage to our partners around the world. Through cutting-edge lubrication insights and expertise, our Equipment Builder Group will take on tomorrow's challenges as it has for the past 100 years. Our agenda for today's webinar contains a short overview for the energy market and fuel demand for electricity production, a view on gas engine trends and equipment manufacturer demands, the challenges with biogas, the considerations and opportunities, best practice and consideration for gas engine lubricant selection, the real-life benefits with results from field engines, and last but not least, a question and answer session at the end. So, starting with a short overview for the energy market and fuel demand for electricity production. The world's demand of electricity will grow a lot in the future, as seen in the graph on the left side of the page. To provide the growing demand for residential and commercial electricity, combined heat and power plants equipped with gas engines will show a very high efficiency and are able to use various sources of fuel gas. See on the right graph. The area of produced electricity and heat, the combined heat and power area, as shown in the right graph at the top in purple, will have the strongest increase. And also the red area for gas as fuel is growing. To get more detailed information on the future demand on energy, please have a look on the ExxonMobil Outlook for Energy, a view to 2040 on our exxonmobil.com webpage. Coming to the view on gas engine trends and equipment manufacturer demands. To meet the market requirements, the gas engine manufacturers need to offer and develop gas engine models who are able to fulfill the demand for inexpensive, sustainable and reliable power. As the global demand for inexpensive, sustainable and reliable power increases, natural gas is increasingly seen as a good option for power generation. As the use of gas grows, it is a fact that the number of stationary gas engines will also increase. A good understanding of the gas engine equipment builder requirements is essential to ensure lubricant meets the needs of this changing and challenging market. The gas engines have to operate with increasing number of different gas types from different sources, like landfill sites, sewage sites, or digestion sites, and needs to deliver electricity and heat with the highest efficiency. Selected for one fuel gas type, like biogas, the engine design needs to handle variable gas quality from the biogas source. This varying gas quality will be the main challenges in the coming years for the equipment builders, as Felix Kiefer, fluid technical expert at Caterpillar Energy Solutions, mentioned in an interview. Also, the use of gas engines for balanced energy and peak load operation will be a main challenge, because the typical continuous operation for balanced energy of the gas engine can be replaced by a start-stop operation to fulfill the peak load demand in electricity production. All these aspects will have a big impact on the development of our gas engine oils. Gas engine manufacturers develop their engines for a wide range of applications and available fuel gas quality. The key elements for the equipment builder of the gas engines are low operating costs, high and easy usability, and good serviceability of their engines. Having the right combination of latest designed gas engine technology for the available fuel gas quality will lower the environmental impact of electricity production, will enable high engine power density and efficiency for a long time. Gas engines with long service intervals, long oil drain intervals, and extended engine lifetime will help to reduce the downtime of the engines. The key element for the owner and operator of the gas engine equipment is to select a fair cost lubricant to meet his objective to decrease operating cost. That includes to use the right gas engine oil quality in combination with the best balance between a long oil drain interval and the best engine protection. The right oil quality and oil drain interval protect the engine from wear, keep the engine clean, and secured with high-quality used oil analysis like our Signum system, will make the owner and operator able to improve his engine efficiency and will enable him to reach longer service intervals and longer lifetime of his equipment. Easily available lubricants and user-friendly lubricants are also important for the customer. We have a well-developed global network of authorized distributors who meet stringent requirements related to product quality and handling, training and qualification. We work closely with them to ensure you are able to extract maximum value from our industrial lubricants. To locate one of our distributors in your country, use the Mobile Distributor Locator tool on our mobileindustrial.com webpage. The challenges with biogas, considerations and opportunities. But first, I now re-hand over to Annabelle for the first quick poll.
Thank you very much, Oliver. So, audience members, it's now time for the first poll, which will be running in today's session. Please select the answer that is relevant to you and then click submit. Today's polling question and selection of answers are: what do you think is the biggest challenge facing the biogas engine sector? Uncertainty around subsides, capital investment required, current low cost of traditional fuels, low power output to cost ratio, flexibility of supply to grid. Please click submit when you select an answer, and then we can take a look at the results. Okay, so if we take a look at the results now. We've got very close results here, Oliver. And the lowest result is flexibility of the supply to grid. Why do you think that is, Oliver?
Yeah, it's. I think the results looking like I have expected them. So it's more than one parameter that is important for the electricity production and also for the biogas sector. So it is exactly what I have expected, yeah.
Excellent. Audience members, thank you very much for taking part in the first part of today's session. Oliver, do continue with your presentation, please.
Yeah, thank you, Annabelle. So, get on to the slides. So, biogas as fuel gas for gas engine in combined heat and power plants is a fast-growing area of gas engine application. On the graph, you can see the number of installed biogas plants in Europe by 2013. So more than 14,000 biogas plants from digestion are installed. To select the right gas engine oil for a biogas application, it is important to know the source and composition of the fuel gas in combination with the engine manufacturer and engine model. On this slide, you can see the range of sources for biogas. The biogas can come from agriculture crops and residues, from sewage sites, from landfill sites, from animal residues, from industrial residues, forestry crops and residues, or a combination of several sources. Looking at the landfill gas. To operate a gas engine with landfill gas, the challenges are the siloxane content and the variable gas quality in general. Siloxanes are forms of silicon which are combined with oxygen and methane in a linear or cyclic arrangement. These are generated from the disposal of products such as cosmetics, shampoos, deodorants, suntan creams, silicone polish, etc., and creates deposits in the combustion area of the engine. Other harmful landfill gas contaminations like hydrogen sulfide or halogenated components can react in the combustion process to form aggressive components in the gas engine. The hydrogen sulfide and halogenated components react with water in the combustion process to form sulfuric, hydrochloric, or hydrofluoric acid. These can be very corrosive, and if they are not dealt with, engine damage can occur in a very short period of time. The lubrication challenges for landfill gas applications are to counteract against aggressive contaminants and to neutralize them, to reduce and control wear and piston rings and cylinder liners in presence of deposits from the siloxanes, and to extend oil drain intervals as requested from most owners and operators. So now have a look on biomass sewage gas. For biomass or sewage gas applications, the challenges to operate a gas engine with are the contents of hydrogen sulfides and the variable gas quality in general. Sewage gas is formed from the bacterial decomposition of sewage sludge, agricultural or vegetable waste. Sewage gas contains varying contents of hydrogen sulfides and siloxanes as contaminations. The methane content is also varying, typically between 50 up to 70%, combined with 20 up to 30% carbon dioxide and high gas humidity. The lubrication challenges for biomass and sewage gas applications are to counteract against aggressive contaminants due to the higher corrosion potential in sewage gas applications, because the sewage gas or biogas tends to have a high moisture content to form sulfuric acid during the combustion process with the hydrogen sulfides, and to extend oil drain intervals as requested from most of the customers. So having a closer look to the siloxanes. Landfill, biomass and sewage gas can contain up to 1% by volume of halides, volatile organic components, and siloxanes, depending a lot on the selected site. Cosmetics, shampoos, deodorants, suntan creams, silicone polish, etc. are common sources for the siloxanes. Siloxanes form silicon dioxide in combustion chamber of the gas engine, resulting in accelerated wear in cylinder liners and piston rings. Gas engine builders set specifications for gaseous fuels to ensure engine durability by setting limitations for the fuel gas contamination and also for the contamination in the used gas engine oil. Traditional gas tests that can show level of hydrogen sulfides or halogenated compounds do not detect these siloxanes, and special tests need to be carried out in order to determine any potential problem before installing an engine. In service, the effects of the siloxanes rapidly show up in used oil, and silicon levels over 50 parts per million can lead to problems depending on the engine type. In the combustion process, the siloxane molecules came apart, leaving behind silicon and oxygen, which recombine to form silicon dioxide, more commonly known as sand. The surplus oxygen in lean burn engines makes them more vulnerable to problems than stoichiometric engines. As well as being abrasive, the silicon dioxide combines with oil and oil ash to create lacquers on the liner and liner scuffing, as shown in the right picture. Silicon dioxide creates also hard deposits on the exhaust valves. Heat transfer on the exhaust valve phase is reduced and valve burning is common. Piston skirt and warming tracking. Landfill gas contaminants who forms acids and silicon oxides can be reason for piston skirt damage due to corrosion and wear, like etching patterns and worm tracking. The pits at the piston skirt contains typically contaminants consistent with the burned landfill gas. Like shown in the pictures, the green area of the pit indicates silicon deposits. The blue area indicates the aluminium from the piston surface itself. You can see the deposits in the piston skirt pits are predominantly composed of silicon. Along with outstanding anti-wear and anti-scuff performance, our Mobile Pegasus 605 Ultra 40 offers exceptional carbon and varnish deposit control, mitigating some of the challenges of operating engines on biomass and landfill gas. Contaminants such as halides, sulfides, and siloxanes, which can be present in high level in these gases, can accelerate wear, compromising engine durability. Mobile Pegasus 605 Ultra 40 is formulated to overcome the challenges posed by impurities that exist in gases from landfill, and it can simultaneously help customers improve power output by extending oil drain intervals and protecting the engine against corrosion, wear, and deposit formation. Now I will hand over to Annabelle again for another quick poll.
Okay, thank you very much. Audience members, it's now time for the second poll what we'll be running in today's session. Please select the answer that is relevant to you and then click submit. Today's polling question and a selection of answers are: what is the biggest operational challenges for gas engines running on biogas? Safety issues, variable biogas quality, regularity of maintenance, or cost of maintenance? Please click submit when you pick your answer. Okay, we can take a look at the results now. Okay, so quite a large percentage there of 75% on variable biogas quality. Are those results interesting to you?
Yeah, so as I have mentioned on the slides before, and mentioned also by Felix Kiefer from the Caterpillar Energy Solution, so it is the biggest challenges to handle the various biogas quality. Yeah, that's it.
Okay, great. Thank you very much, Oliver. So I'd now like to introduce our second presenter in today's session. So Kathy, please take it away when you're ready, and welcome everyone. Kathy Tellier.
Thank you very much, Annabelle and Oliver. Really a very excellent overview of the biogas and landfill markets. I would now like to discuss our most recent product development effort, which Oliver has discussed briefly with you, Mobile Pegasus 605 Ultra, a project that I've been personally involved in, and I'm really happy to share some of those results with you. But first, let me start with just some general background on the gas engine lubrication requirements. Gas engine oils are required to perform multiple functions within the engine. Here's a cross-section of a power cylinder assembly to help illustrate the requirements. Number one, it needs to control spark plug fouling to prevent misfiring. It also needs to control piston ring wear and ring groove cleanliness to prevent ring sticking, bore polishing, and to minimize lube oil consumption. It's responsible for controlling liner wear, lacquering, and corrosion, and to minimize lube oil consumption and to prolong engine life. It's responsible for the load-carrying properties and to maintain a proper oil film to reduce friction and wear. It also helps to control foaming and is responsible for minimizing volatility, which also will minimize lube oil consumption. In terms of the exhaust gas, we also ensure that the lubricant components have minimal impact on catalyst. We also optimize the ash deposit to balance valve recession and deposit formation. Typically, the ash level is 0.5% sulfated ash, and that's what's required by most gas engine OEMs. Oil life is always important to our customers, and so we formulate our lubricants to maintain proper oxidation, nitration control, viscosity increase, so that we can extend oil drain intervals and increase productivity. Lubricants can also play an important role in terms of reducing fuel consumption, as has been demonstrated by one of our latest products, which is Mobile SHC Pegasus. And the lubricant is also responsible for heat removal. And our approach is that a balanced formulation is really essential to meeting all of these requirements. Pegasus gas engine oils are unique in that they are component-based formulations. This means that each of the additives and base stocks are selected specifically to provide the best performance. This formulation approach allows Pegasus gas engine oils to differentiate themselves versus the competitors, many of which use additive packages. The goal when formulating Pegasus gas engine oils is to provide balanced performance, as I stated earlier. This is best illustrated through the use of the chart shown here. This chart is for Mobile SHC Pegasus, the world's first energy-efficient gas engine oil. This chart compares the performance of Mobile SHC Pegasus and conventional mineral-based gas engine oils in several key areas: energy efficiency, oxidation control, nitration control, additive retention, viscosity control, and deposit control. Clearly, mobile SHC Pegasus provides the best overall performance. So I'd like to now turn it back over to Annabelle for the next quick poll.
Thank you very much. Okay, audience members, it's now time for the third poll. So same again, please select the answer most relevant to yourself. And the question is, which two criteria are most influential to your decision making when selecting a lubricant for your equipment? Price, OEM recommendation, energy efficient benefits, ability to extend oil drain intervals, or equipment protection. Again, please press submit when you pick your answer. Okay, so we'll take a look at the results now. Okay, Kathy, we're quite close there, but it is OEM recommendation with the greatest percentage of 36.5%. What do you think about those results?
I'm not surprised at those results. I think, and we also agree when we develop our gas engine oils, we're always very interested in obtaining the OEM endorsements for those products. And we do that through a very extensive field test program, which can range anywhere from 4,000 hours of testing in the field to over 10,000 hours of field testing. So we definitely agree with that, what the audience has indicated. I also agree that the ability to extend oil drain intervals and equipment protection, they also came in quite high. So certainly that has always been our goal, to increase productivity for our customers, and we do that through exactly that way. So that's really great results there.
Excellent. Thank you very much there, Kathy and audience members, and please do continue with your presentation.
Okay, so now I'd like to share with you the latest Pegasus gas engine oil development, Mobile Pegasus 605 Ultra 40. Mobile Pegasus 605 Ultra 40 was formulated to improve engine reliability and extend oil life in high-severity landfill and biogas applications. Mobile Pegasus 605 Ultra 40 represents the latest in the 50-year history of Pegasus gas engine oils. Mobile Pegasus 605 Ultra was tested in side-by-side engines with current Mobile Pegasus 605. Mobile Pegasus 605 Ultra was able to provide equivalent to improved engine durability and piston cleanliness in areas of wear, corrosion protection, and deposit control at double the oil drain interval. This chart shows the results from a fuel gas analysis that was conducted during the field trial. It points out the wide range of siloxane and silicon results that are possible with different test sampling methods. From the perspective of the engine, all siloxanes, regardless of the species, are detrimental to engine durability. And Oliver talked a little bit about that earlier. This side-by-side engine field test results demonstrated that Mobile Pegasus 605 Ultra can deliver double the oil drain interval versus Mobile Pegasus 605. Mobile Pegasus 605 Ultra can provide improved productivity to landfill customers via extended oil drain intervals, improved engine durability, and deposit control. This field test started at 400-hour oil drain intervals with Mobile Pegasus 605, and we were able to extend the oil drain interval to 1,000 hours, over double the oil drain interval by the conclusion of the test. These charts show the kinematic viscosity and oxidation trends of Mobile Pegasus 605, that's shown in green, and Mobile Pegasus 605 Ultra, shown in pink. And this is over the entire test duration. This slide shows the used oil analysis trends for TBN, or total base number, and TAN, total acid number. Mobile Pegasus 605 Ultra provides directionally improved TBN retention and TAN control at double the oil drain interval of Mobile Pegasus 605. These two charts also show the used oil analysis trends for nitration and a key wear element, copper. Mobile Pegasus 605 Ultra provides equivalent nitration control, again at double the oil drain interval of Mobile Pegasus 605. After an isolated copper spike at 3,000 test hours due to a shift in fuel gas severity, Mobile Pegasus 605 Ultra provides equivalent corrosion control performance at double the oil drain interval compared to Mobile Pegasus 605. In addition to monitoring of used oil parameters, we also conduct a full engine inspection at the conclusion of all of our field tests. Mobile Pegasus 605 was evaluated for its impact on engine durability, specifically cylinder liners and connecting rod bearings as shown here. You can clearly see an improvement in scuffing resistance and wear performance with Mobile Pegasus 605 Ultra. Piston cleanliness was also evaluated during the field test. Here are the before and after photos of two pistons. Clearly, there are less deposits on the piston lands and grooves, demonstrating the excellent deposit control performance of Mobile Pegasus 605 Ultra. We also evaluated the deposit control performance by inspecting the piston crown and combustion chamber. Here are the before and after photos of the piston crown. Clearly, again, demonstrating the improved deposit control performance of Mobile Pegasus 605 Ultra. Mobile Pegasus 605 Ultra provided excellent oil life and engine durability in this 18,000-hour high-severity siloxane field test. I will now conclude the presentation with a discussion of future trends and a summary. There are several trends in the gas engine oil industry. They include energy efficiency, which results from higher compression ratios and operating pressures and temperatures. These conditions greatly increase the demand on lubricant performance. ExxonMobil is an industry leader. With the launch of Mobile SHC Pegasus, the first gas engine oil which has the potential to deliver up to 1.5% reduction in fuel consumption. Another trend is towards lower emission requirements. This results in an increased use of after-treatment devices on stationary gas engines and more focus on protecting those investments. Lower emission requirements also are impacting the types of applications where gas engines can be implemented. In conclusion, there are many specific challenges within the biogas and landfill industry, such as those posed by the impurities that exist in the gases from landfills. It is crucial to select the right lubricant for your operation. Plants can accrue significant savings with the implementation of an advanced gas engine oil which can protect gas engines. Choosing the optimum lubricant for your operation can help to increase productivity, reduce downtime, and save on maintenance costs. For further guidance on selecting the right lubricant for your operations, please contact the Technical Help Desk or your local mobile lubricants distributor. At this time, I think we're going to respond to the questions that you have provided during the session.
Okay, Kathy, thank you very much. So, audience members, as Kathy just said, it's now time for our Q&A session. So please do send in any questions or thoughts that you may have for Oliver or Kathy, and hopefully we have enough time to address those in the Q&A session. So I'm going to go straight into the Q&A now with our first question, which is, what are the most important used oil parameters when monitoring landfill gas engines?
Thanks, Annabelle. I can take that question. Landfill and biogas applications are unique, and oil life is largely determined by the contaminants that are found in the fuel gas itself. For example, in landfill applications, it is important to monitor wear metals, such as iron. And I think you saw some of the earlier photos where we saw some scuffing in the liners, and that what you will see that those iron levels increase in the used oil. And that's an indication that the siloxanes are having an impact on liner wear. It is equally important to monitor kinematic viscosity increase, oxidation, and total base number, or TBN, since these parameters all provide a picture of remaining oil life.
Yeah, in addition to that, normally the equipment builder have set on each of these tested parameters some limitations, and normally if you are guided for the limits on these parameters, the engine life is secured.
Okay, thank you very much for that question. The next question we're going to take now is, has Mobile Pegasus 605 Ultra been field tested in any other gas engines?
That's good. Great question. I can take that one, Annabelle. Yes, absolutely. In addition to the GE Waukesha APG 1000 field test site that I described during this webinar, Mobile Pegasus 605 Ultra is also being field tested in Caterpillar and GE Yembacher engines in both biogas and landfill applications.
Yeah, and additionally, we are testing in MWM engines and MAN engines, also biogas and landfill.
Okay, thank you very much for that question. The next question is, how do siloxanes impact gas engine reliability?
Yes, I can take that question, Annabelle. And I think, Oliver did a pretty good job. He was explaining in some of those photos, the liner scuffing, the worm tracking. Siloxanes are very common in the majority of the landfills and biogas applications. And when the siloxanes enter the combustion chamber, they actually form silicon dioxide, which is more commonly known as sand. So as you can imagine, that when it combines with the ash from the lubricant, it forms a very abrasive deposit. And that results in liner scuffing and accelerated piston ring wear, greatly increasing the maintenance requirements for engines in those applications. Mobile Pegasus 605 Ultra has demonstrated very good wear performance in these type of applications and in the presence of high levels of siloxanes in the fuel gas.
Okay, thank you very much for that question. The next question we're going to go to is Mobile SHC Pegasus suitable for landfill or biogas applications?
Yeah, I can take that one, Annabelle. Mobile SHC Pegasus has been formulated to handle up to 1,000 parts per million of H2S, or hydrogen sulfide. So if the biogas application is a mild application where they are doing some type of gas cleaning or filtration, then mobile SHC Pegasus may be suitable.
Thank you very much, Kathy, for that. The next question what we have come in is, what type of oil can we use under these conditions?
Yeah, so maybe Annabelle, I can take that. So as the mobile Pegasus gas engine oil is a series of products, it indicates that there's no general answer for all of that applications. So in every case, normally the best way is to have a look on the fuel gas quality and on the equipment that is used on that application. And in combination of both, normally we make a recommendation for a special product out of our mobile Pegasus product line.
Okay, thank you very much for that question. The next question is, what will be the worst case effect of gas type variation to the lifetime of critical machine components, and which components are mostly affected?
Yeah, that's a great question. I can take that one, Annabelle. I think in landfill, I'll start with landfill applications because that's what we've discussed with the Pegasus 605 Ultra field test. Some of the key areas that siloxanes can have an impact on are the liners. And I showed you how 605 Ultra could provide improved scuffing resistance in the liners. We also saw some improved connecting rod bearing wear performance. So these are areas that are greatly impacted by siloxanes. So siloxanes do form very abrasive deposits and cause the liner scuffing. They can also, as you saw in one of the slides that Oliver presented, they can result in worm tracking of the piston skirt. And that's another area that we found that within the tracks on the piston skirt, you can actually find silicon elements, which are traced back to the fuel gas. So those are some of the areas that are greatly affected by the presence of siloxanes. There are also other contaminants that you find in landfill or biogas, which can include halogenated compounds, H2S, and those in general have a very corrosive impact on different components, which may include different bushings that are found in the engine that are either bronze or copper. They can have an impact on copper coolers, the components that are found on the oil coolers. And so it really depends on what type of contaminants you find in your fuel gas. And it also points out the importance of having a fuel gas analysis and understanding what the contaminants are that the engine is expected to deal with.
Yeah, and for example, also for natural gas applications, if there are components like propane or butane or like hydrogen, they have very low performance on compressibility and pre-ignition tendency. And that results typically in knocking. And if the engine is not prepared with knocking sensors, then it results in extremely high temperatures and high pressures. And okay, that will also have a high wear performance, high wear for the engine then. So also natural gas components with a low methane number will impact the engine durability or lifetime.
Okay, thank you very much for that question. The next question is, what is the difference between Pegasus SR and Pegasus 605 Ultra? Has Pegasus 605 Ultra the same base oil as SR, but a different additive package?
Good question. I can take that one, Annabelle. So as that the author of that question is probably aware, there is a current product in our product line called Mobile Pegasus SR. SR stands for scuffing resistant. It's been in the market, I would say 7-8 years, and has really provided excellent wear performance and oil life in landfill applications. Mobile Pegasus 605 Ultra is the next generation of this product and utilizes some of the same additive technologies as Pegasus SR, with improved base stock quality to improve oxidation, stability, and extend oil life.
Okay, thank you very much for that question. The next question is, does Mobile SHC Pegasus have OE endorsements?
Could you, Annabelle, could you repeat that question, please?
Yes, of course. Does Mobile SHC Pegasus have OE endorsements?
Yes, it does.
Yeah,
I can take. Yeah, go ahead, Oliver.
Yeah, so the SHC Pegasus is approved by Waukesha, and in that area it is for the SHC Pegasus 30, includes the fuel efficiency possibility for the application. And in addition, we are testing at the moment the SHC Pegasus 40 brand to get approvals from other major builders.
That's right, Oliver. And we also have a preferential endorsement for Mobile SHC Pegasus 30 with KHI, who is a major Japanese gas engine OEM. And we've conducted numerous field tests in both Caterpillar and other Waukesha engines in the United States.
Okay, thank you very much for sending in that question. And the next question is, with the advanced lubricants, is there any data showing reduced engine oil consumption?
Good question. I can take that one, Annabelle. Yes, in fact, with Mobile SHC Pegasus, the SA30 viscosity grade, we did extensive field testing with that product in the Waukesha engines. And in those applications, we were able to see, if you look at the two components for lube oil consumption, is number one, the extending the oil drain interval, and number two is being able to reduce the daily makeup consumption that occurs within a gas engine. And in the case of Mobile SHC Pegasus, we were able to see number one, extension of oil drain intervals anywhere from 4 to 8 times conventional gas engine oils, and we were also able to see a 30% reduction in daily makeup consumption. So all totaled, that would equates to roughly a 50% reduction in lube oil consumption.
Okay, thank you very much for that question. The next question is Mobile SHC Pegasus mixable with the mineral-based Pegasus oils?
Yeah, so maybe I can take that, Annabelle. So in general, they are mixable, but also in general, we have to say to keep the performance of the mobile SHC Pegasus in your equipment, it is better not to mix it. So if you want to change from a mineral-based gas engine oil to our mobile SHC Pegasus, you can bring it in after an oil drain, having a short running period with a mixture, and then drain again and fill up with the mobile SHC Pegasus. That already also includes that the used oil samples you will send into the used oil lab has the results of that sample only from the SHC Pegasus and not from a mixture, so that the results are for the mobile SHC Pegasus only, and the used oil limits can apply it.
Okay, thank you very much for that question. The next question is Mobile Pegasus 1005 applicable in biogas application?
Yeah, that's a good question. As I had stated with Mobile SHC Pegasus, there was a question on that and using that in biogas. Mobile Pegasus 1005 is also formulated to handle up to 1,000 parts per million of hydrogen sulfide, or H2S. So depending on your fuel gas analysis and the level of H2S, if it's below 1,000, then Pegasus 1005 should be perfectly suitable for that application.
Okay, great. Unfortunately, audience members, that's all we have time for in today's Q&A session. I'd like to thank everyone who sent a question in, and I do apologise if we didn't get to answer your question. Hopefully, we will be able to answer those at a later stage. Kathy, Oliver, do you have any final remarks you'd like to leave us with before I conclude today's session for us?
No, I'd like to thank everyone for their participation. Really enjoyed the questions and the interaction with the quick polls. And thank you, Oliver, and thank you, Annabelle.
Yeah, also thanks from me to the audience for the very good questions at the end, and also to Kathy for the good presentation, and Annabelle for hosting us.
Thank you very much. So again, that just leaves me to thank Oliver Glove and Kathy Tellier for what was a great presentation, and to also thank ExxonMobil. To the attendees, you'll receive an email shortly telling you how you can access the on-demand version of this webinar. You can access this through our website also, which is www.business-review-webinars.com. Once this webinar ends, today's survey will appear, and we would appreciate it if you look at the questions here. We look forward to sharing further webinars with you, so please do keep an eye out on the website just mentioned, and follow us on Twitter at BR Webinars for daily updates, and join our LinkedIn group, Business Review Webinars. Thank you once again, and I hope you all have a nice day.